Hello everyone, this is Ketisha. In this video, I'm going to go through the AQA Physics Paper 1 higher tier from 2023. Question number 8 is on the topic of atomic structure. Scientists developed new models of the atom as new particles were discovered. Draw one line from each particle to the year it was discovered. Now, you don't really need to remember the years, but you do need to remember the order in which they were actually discovered. So, the earliest or the first particle that was actually discovered was actually the electron. So, which is in the 18th century or the late 18th century. And the neutron and then the nucleus. Now, the neutron was the one which was actually discovered the last. The, the electron was discovered and then the proton was discovered. So, we have the proton as well here. So, this is going in order. The years are actually going in order. Now, following the discovery of the electron by Ernest Rutherford, he came up with the plum pudding model. And in that model, he described the atom with the electrons simply dotted around and the entire atom to be a positive charge. Now, after that, the gold leaf experiment was actually conducted, which led to the discovery of the nucleus. Nucleus is actually the second structure, and that led to believe that the atom is mainly empty space. Once the nucleus was discovered, then the proton was discovered. Third, that it's a proton that has a positive charge, and finally it was the neutron that was discovered. Now, discovering the neutron actually took a lot of time because it didn't have any charge, so detecting it was really hard. The nucleus was discovered using an alpha particle in particle scattering experiment. Alpha particles were directed to a sheet of gold foil. Figure 8 shows the paths taken by 7 alpha particles A to G. So you can see in the particle A, which is going near the nucleus, which is actually bouncing off straight back in the direction the alpha particle actually was emitted from. B and C were deflected. D to G went in a straight line. The question: explain why alpha particle A takes the path shown in figure 8. Why did the alpha particle shown in figure 8 actually bounce off? Now, the alpha particles, what we need to remember is a helium nucleus. Because it's a helium nucleus, it has 2 protons and 2 neutrons. Now, 2 protons carry a positive charge and the neutrons don't carry a charge. So, alpha particles generally have a 2 plus charge. Now, if it's a positive charge, these are all alpha particles. For it to bounce off, the nucleus should be positive as well. So, why did it actually bounce off or repel? Both the alpha particle and the gold nucleus carry the same charge, which is positive, hence they were repelled. So, both alpha particles and the gold nucleus have a positive or the same charge. So, the alpha particle and the gold nucleus repel each other. So, the Marxist actually comes for saying that it have the same charge and that they repel each other. Let me redraw that line. Question 8.3. Explain why the path of alpha particle B is more slightly curved than the path of alpha particle C. Now, if you look in the diagram again, B is actually much closer to the gold nucleus than C. Now, as you go further away from the nucleus, the charge actually decreases from the gold nucleus. Hence, C is not repelled as much as B is, and while D, E, F, and G are not repelled at all. So the answer, particle B passes closer to the nucleus, so experiences a stronger repulsive force. That gives you the second mark, or you could say, so experience a stronger electric field. Question 8.4. What can be deduced about the atom from the paths taken by alpha particles D, E, F, and G in figure? The atom contains a nucleus, not necessarily the atom contains protons, neutrons, and electrons. No, the atom is mostly empty space. Yes, that's what the main conclusion was. That's why most of the particles pass through the gold foil. 8.5. How is the Bohr model of the atom different from the nuclear model of the atom? Now, the nuclear model is where you have the nucleus and the electrons going around in circles. This is what we use in chemistry commonly. The Bohr model was actually developed further later on, and it's actually a development from the nuclear model. Now, in a nuclear model, it simply simplifies that the electrons are in fixed positions going around in a circle called the orbits. Whereas in a Bohr model, it's much more specific the way it's actually founded. So, in the Bohr model, the electrons orbit the nucleus at specific distances, which we call the shells, whereas in the nuclear model, the electrons can orbit at a continuous range of distances. Question 8.6. Explain how an electron can move up and down energy levels in an atom. Now, the shell, if an electron is found nearer to the nucleus, we say it's higher energy level. If it's further away, then it's lower energy level. So, how can it move up an energy level? For an electron to move up an energy level, it needs to absorb energy. For it to move down, it needs to emit that energy. To move to a higher energy level, an electron absorbs energy from electromagnetic radiation. To move to a lower energy level, an electron emits energy in the form of electromagnetic radiation. So here you can actually electromagnetic radiation in the form of gamma radiation, and sometimes it can be infrared radiation. When you heat it, and electrons can actually jump to a higher energy level, and when it jumps back down, it releases electromagnetic radiation in the form of light. This is why when you heat things, it glows eventually when this happens. That brings us to the end of question number 8. I will see you in question number 9.